The variance is a very good way of describing how spread out the data is. In the last example, we had Penny getting a variance of 10 and Silver getting a variance of 2.5. And this gives us a single number that we can use to describe the data set. So now we have Penny with a mean of 6 and a variance of 10, and Silver with a mean of 6 and a variance of 2.5. We could also move some of this data around, so we could give Silver a mean of 11, but with the same variance of 2.5, or spread it out until he also gets a variance of 10. That's quite useful. So now we have two numbers that we can use to describe a data set in two different dimensions. However, there is a problem with the variance. And if you look at how we calculated it, you'll see why there's a problem. So if we go back to the formula for the variance, that is the sum of all the differences between the individual scores and the mean of the scores squared over the total number. The problem here is that we don't end up with a score, we end up with a score squared. So for example, if each of these was distances, let's say that Silver and Penny walked, say Silver walked 4 miles, 5 miles, 7 miles, and 8 miles, and you were to say 7 miles minus 6 miles, that's 1 mile squared, you don't get a mile, 1 mile. You end up with 1 mile squared. And you can't use that if you want to graph the differences. If you want to take a look at it, you can't really say, well, this is 1 mile here and this is 1 mile squared there. That doesn't work out as well. Most of the time, we'd rather have everything in the same units. If we're having miles here that we measure in, we want miles again when we report each of them. After all, the mean is in miles, so why can't the variance also be in miles? Well, to get the variance back into it, we do another transformation, which is simple. If the problem is that the variance is squared, the solution is to square root the whole thing. That is the sum of all the differences between the scores and the mean squared over the number of them and the square root of that whole thing. This is a different measure, not the variance, but the standard deviation. And the major advantage of the standard deviation is that it's presented in the same units as the actual units you measured in the first place.